Yeah. Oh, no, no.
Hi everyone, a very warm good morning to everyone. Uh, I am Subhidh Agarwal, IoT lead. I welcome you all to the 2-day workshop. I hope you all will learn very good things and get benefited from those IoT workshop. And without wasting any time, let's get started. So today we will be covering the basics of IoT, what is IoT, and why IoT is in trend or why there is so much fuzz about IoT, then the reasons, and we will the reasons, and at last we will have some hands-on. Okay. At first, we'll see what is IoT. So, Internet of Things usually describes as internet with objects or what we call as things that are embedded with sensors, software, and other technologies. These sensors are often used in collecting data and exchanging it with other devices. It exchanges data with other devices over internet and other systems. These devices range from everywhere like home, industry. In sophisticated words, it was the Internet of Things or uh, Internet of Objects. What is it in layman words? Layman words, it can be defined as any object which can be connected to sensors and exchange data, visualize them, and make decisions based upon it. Why is IoT trending? Uh, the most important reason why IoT is trending because we got the ease to internet. The components are very less price, and the important thing, it exchanges data with minimal human interaction. What is minimal human interaction? Minimal human interaction is those devices are always autonomous. You don't need to interact with them. You just connect those devices and let them work on their own. IoT and its growth. The Internet of Things came into boom when large industrial based companies started making their own IoT systems. This was the year when it was defined as Industrial Internet of Things, which is IIoT. This was roughly in 2010, and currently now in 2022, there are approximately 50 plus billion active IoT devices. IoT and its growth. The reasons why IoT came into boom in 2005, the availability of chips or components got much easier. In 2010, everyone had internet access. In 2015, almost 70% of the people had smartphones, and which was connected to obviously internet. And the upsurge in tech in 2018, that was the fascinating smart cars, smart homes, smart industries, and everything. And now we are in the IIoT phase. The applications of IoT. IoT is not just limited to one or two places. IoT can be used in every field which you think of. Field like industries, field like homes, even in farmings. So applications of IoT, smart home, uh, all appliances like your fridge, thermostat, heaters, lights, curtains, everything is connected. Smart cities, everyone of you have heard of it. Traffic monitoring without any traffic men, fleet management, agriculture, hospitality, waste management, water management, and so on. This list is never ending. Now we'll discuss the components of IoT. There are three main components which we'll discuss. The first is source. Source is the sensors and the board collectively. The sensors alone can't uh, keep data or store data. It needs the help of boards. The second component is data processing. After we collect the data from the sensors and board collectively, uh, we either uh, compute it on board, fog based, or cloud. The third and the last component is visualizing or decision making. When we collect these data, process them, either we visualize to see trends and or we make decision based on them. What are boards? Boards are printed circuit boards with circuitry and hardware design. If we get a plain microcontroller, it will be very difficult for us to connect pins and everything. So we get development board. Development boards are uh, microcontroller which have every pins and stuffs connected to it so that it makes our work easier. The two main boards we will discuss in this 2-day workshop: Arduino based, which includes Arduino, Node MCU, etc., and Raspbian based Raspberry Pi. What is Arduino? Uh, Arduino is a microcontroller. The microcontroller name is AT Mega 328, and the board name is Arduino Uno. It has 14 digital pins, out of which 6 are PWM, which I'll explain later what is PWM, 6 analog pins, and a USB port, power jack, and this one is our microcontroller. I'll explain this in brief later. What are sensors? Sensors are devices that connect and respond to some type of input from the physical environment. Um, Physical environment as in temperature, humidity, etc., etc. There are two types of sensors, mainly analog and digital. What is analog? Analog sensors can measure continuous data, like it can go from 0 to 1000 with continuity. What is digital? Digital gives only two values, 0 or 1. We'll show various types of sensors available in the lab. The first one is ultrasonic sensor. It is used to measure distance. IR sensor for proximity. DHT, DHT digital humidity and temperature. We have other sensors like this is pH sensor. It measures the pH level of any liquid. Uh, we have electrolyte sensors, and there are many more sensors. Like this is a small sound sensor. It can measure sound very accurately. Uh, this is rain sensor, or you can say water sensor. Any changes in the on the surface changes the reading. This one is for tracking. This is buzzer, and we have many more. Like this is mini two LED, two color LED. Okay, like this part. This part is small LED. The most important gas sensor. It measures. There are many different kinds of gas sensor. It measures alcohol, CO, CO2, NOx, SOx. and many more. Okay, so we are done with the sensors. We'll start with our hands-on for today. The first thing we'll learn about Arduino. Okay, so this is Tinkercad, a online simulation platform where we can simulate other every board and its component. What is component? Components are either sensors, input, output. Okay, so we'll search for Arduino, Arduino. Arduino will get mini Arduino, then drag and drop to the main screen. It is just just a copy of our physical Arduino. You can see this way. Uh, this is our power plug, which you can see also in the simulation. Power plug, both we can use this as power plug and this, but this is also used for data transfer from your PC, and other pins also you can verify that they are very same. We'll start our first project for the day. First, we'll start on Tinkercad, a basic LED blink program. uh, Drag a LED, drag a resistor. Why is resistor used? Resistor is used that excessive of power from Arduino don't burn our LED. Okay. Uh, so I said before, VCC you can think of plus, which gives power, and ground the negative. So what we'll do? It is very good practice to use a breadboard if you are a beginner. And it's also a very good practice that first we drag a 5 volt or the VCC or the V to a pin in breadboard. Okay, the breadboard, I'll explain what is breadboard. Breadboard is a small board in which pins are connected. Okay, how is pins connected? uh, the last, the extreme columns, you can see this and this, the pins are connected horizontally, and the pins in between uh, is connected vertically. I'll show the video too. This is a large breadboard. This pins are connected horizontally, like from this hole, this hole is connected till here. This is connected till here, and same for the second row, same for this, and the middle columns are connected uh, vertically, like these all are connected, these all are connected. So whenever you start making a project by yourself in physical mode, always uh, pay attention to what wires you are connecting, because if VCC and ground touches, the board may short circuit, and uh, this will be just a waste. So first we will connect 5 volt, and this line, as you know, this line is connected. A ground or minus, which I said, to the other pin. It is always a good practice to change colors, like for ground brown and VCC or 5 volt keep red. We need to connect a LED. So you know this is connected vertically. And one more thing, LED. If you see physical LED, you'll notice the length of the both pins are different. Can you see? Now can you see? Both the pins length is different. Okay. Uh, the longer one is the VCC, or we say is plus, and the shorter one is minus. In Tinkercad, the curve one is plus and the this cathode minus. Okay, so we uh, connect a resistor, because it may burn your LED. Bring a 5 volt to resistor, from resistor to plus, and from minus to ground. I hope everyone get this. Uh, if you want the change color of wires, change it. Go to the code, go to text. I'll explain the program. It's written in language C++. The void setup function, whatever pins you define or whatever things you need to define first should go in void setup. Whatever things you need to run in the loop goes in void loop. Okay, so we'll see first it is if the LED is working or not. We just start the simulation. Okay, I found the mistake. What was it? The breadboard pins are connected here vertically. I connected these two pins. So the power transfer is disconnected here. So I need what I need to do this that I need to bring this wire to this in any of these pins. Okay. So I'll press delete in my keyboard. The wire got deleted, and bring a wire from here to here. Okay, I'll start simulation. You see, you can see the LED was on. Okay, I'll stop the simulation. Now we need to learn the first basic program of today, that is blink. How to blink this LED with an interval of 1 second. So this 5 volt or this 3 volt gives a power output continuously. This can't be controlled. The power output of 3 volt and 5 volt can't be controlled. So what we do, we use these digital pins. Digital pins is used to give power. It will be how we define in the code. If we give output, these pins will provide output. If we type input, this can read data from the sensors. What we need to do, uh, we need to first delete this wires which we connected directly from the 5 volt. Okay, so let the ground be connected because every electronics needs a ground, and we will connect any pin. From any pin you can connect to the resistor. I'll connect it like a resistor, and from the other terminal of resistor bring a wire to the LED. We'll go to the code section. First we'll define a pin. How to define a pin? We can write int pin number, user defined variable. Pin number equals to the pin number which we have plugged the wire, that is 7. Okay, now we need to find or figure out what is this pin used for. This pin is used for giving output. Then we will write pin mode. In place of LED built in, we will write pin number, the same variable we used here for defining the pin, so that the program knows that we are defining this pin number 7 as output. and we'll write here output. Okay. Uh, okay. After defining all the pins we are using in this Blink project, we will run a loop. This loop function goes on repeating every time. So what we need, we there are two types of function. One is digital read, other is digital write. So what does digital read do? Digital read, digital read, digital read. Sorry. This function takes input from the sensor. It reads the data from the sensor. Okay, it reads data from sensor. What does this digital write do? Digital write gives data to the sensor or to the component which we have plugged in. What it do? It provides data to the component. Okay. So what we are doing here? We are giving a high signal, or you can say a high voltage plus voltage. High voltage can be also said as, not defined as, high voltage that we are powering on the component. Okay. So what is the first step doing? The first step is powering on the component. We will wait for 1 second. Like, see, this is wait for 100,000 milliseconds. 1,000 milliseconds is 1 second. We will wait for a second. Then again, we will turn off the power. What high means? High means, sorry, low. Low means powering off the component. We will power off the component. We'll wait for another 1 second and repeat this code. So I'll start the simulation. And you can see the LED blinks for a second and sit down for a second. Is it visible for you guys? Okay, so this now we will do in the physical mode. We'll take the Arduino as discussed in the Tinkercad. Take a breadboard. Always try to use the side pins for powering, because see, now we are doing only one LED. What if we need to power 10 components? Then these pins come very handy. So what we'll do, we'll put this pin anywhere. Let's just say like 8. Put this here. As discussed before, the longer pin is the plus one. The longer pin is plus and the shorter one is minus. So you need to remember where we are plugging the longer pin. The longer pin is on the left side. So just put the LED up, like this. Longer pin is above. Okay. Take a connection from the longer pin to our the pin from which we will deliver the power. Okay. After that, as told before, we will use a resistor. 220 or 330, 480 ohm resistor is enough. It will not burn your LED. From the positive end of your LED, plug a terminal of the resistor, the other terminal in other part, okay, uh, the power output in the first terminal of the resistor, okay. I hope this is visible, and one to the ground from the minus part of the LED. So from minus part of the LED, we plug into ground. Okay, the connection is complete. Uh, there is a software called Arduino Ide. You can download the zip. You can download the zip file and extract anywhere on your desktop. After you extract, there will be a window like this. Wait, yeah. You will see a window like this with no commands, but we have learned command from our Tinkercad. But we have learned from our Tinkercad. Tinkercad simply copy paste the code. We will check the pin number if we have plugged in the same pins. Here we have plugged in pin number 8. Here in the video we have plugged in the pin number 8, but in the code we have written pin number 7. So we will change it to pin 8. There are many things in Arduino IDE. First, you need to select the board. Go to the tools. Go to the tools. Visible name, go tools. Go to the tools. Find something written as board. It's now showing Arduino Uno. I think there might be nothing in your laptop or computers. Go to the board and select Arduino Uno, the board which we are using right now. Select it. Plug this Arduino Uno in your computer. You will see something called as port. Select the port which has written Arduino Uno. Select and upload it. It will ask you to save your project's name, LED blink, and save it. Okay. Okay, now you can see the LED is blinking. I'll switch off the light. I hope everyone got this, a small beginner level project for understanding how Arduino works and what is the different pin, analog, digital, VCC, ground, and everything. Now we'll discuss some other advanced level projects like using a rain sensor. First, we will do in Tinkercad. Okay. Achha, range. Okay, request the members in the online to open Tinkercad and see if this small LED blink project is working for you guys or not. You can say in the comments if you have any doubt. Our workshop is sponsored by Coding Ninja.
भाई साहब प्लेसमेंट के लिए इन्होंने तब कर लिया, जाप कर लिया, कर ली पूजा पाठ, प्रेप भी कर ली इधर उधर से, पर क्या लगा हाथ। चुनो कोडिंग निंजास। इन्होंने बनाए हैं 50,000 से ज्यादा प्रो कोडर्स, प्लेस्ड इन लीडिंग टेक कंपनीज। कोडिंग में करियर मतलब कोडिंग निंजास।
Uh, so we will resume our workshop again. This time we will be working on a small rain sensor. So what does the rain sensor do? Rain sensor uh, measures the amount of water या फिर rain हो रहा है कि नहीं, ठीक है? So as said before, when I was showing the sensors, this is sorry. This is the rain sensor. This is the rain sensor. This part is the from this part, from this to this is the circuitry of the board, which should avoid water, or from the pin. This pins you see, from this pin to this can come in contact with water. Okay, so we'll start connecting the sensor. I hope it's visible. Okay, it's not visible so much clearly. I'll say the leftmost pin, this one is signal pin. Signal, what signal? It is used to give data to Arduino. Okay, signal, plus as discussed before VCC, and minus as discussed before ground. Okay, so we will connect this. The orange wire is connected to the signal or the data pin. Data pin can go in any of the analog pins. Before we worked in digital pin. Digital pin is used either for uh, power delivery or in accepting data. We used for power delivery in LED. Now we will use analog pins. And what was analog pins used for? Analog pins were used to measure continuous data, that was like 0 to 1024. Okay, so in any of the analog pins from A0 to A5, plug the signal wire. The plus or the VCC is the red, put it in 5 volts, and the brown in the ground. After this, we'll open the Arduino IDE. The two main functions, basic functions. First is void setup and the void loop. First, we need to define the pin. What, in which pin I plugged in the sensor. Okay, so we can write int, a user defined variable. You can pick any name. I'll pick rain sensor, equals to, either you can write simply the pin number like 0, or you can write A0, analog 0. Like you can see the pins, analog pins ranges from A0 to A5. You can write A1, A2, any pin number. In void setup, we define the pin. What is the pin used for? Pin like input or output. So what is the pin we are using for? We are using for inputting the data. The sensor measures the physical environment and sends the data to Arduino. So we'll use input pin mode. Pin mode receives two parameter. One is the pin which we are using. Uh, we are using range sensor pin. What it is used for? Used for input. I discussed before digital write and digital read. Digital read is used to read data, and write is used to deliver data. Here we are reading the data from sensor, so we will write digital read. From what sensor? From what pin? We are using the range sensor pin, so we will write range sensor. We read the data from the digital write function. Now we will store it somewhere. How to store? Use any variable like value. Value equals to digital read the sensor pin. Now we will simply display. For displaying, like in Java we use system.out.println. Here we will use serial.println. Serial in serial monitor. Serial.println. Upload the program to Arduino Ide. Open the serial monitor from the topmost right corner. Select the baud rate 9600 like what we have written here. You can, as you can see, the value is writing very fast. So what we can do, we can put a function called delay. Delay 2 seconds and upload the program again. Now you can see the value of the out, well, like the reading is 0 because the range sensor doesn't sense any water. When a single drop of water falls, see, you can see the changes in the reading. Okay. So what does it show? Like whenever there is water on the sensor, the data will change from 0 to 1. One more thing, like we wrote here digital read, so the value is in 0 and 1 format. If you want to see how much water, we can write analog read, analog, because it's an analog pin. Analog read, upload. Six zero one. This value ranges from 0 to 1024. If I wipe off the water, see the value decreased. And if again I'll see, like you can see the some water drops, the value will increase. After rain sensor, we'll have hands-on on DHT, that is digital humidity and temperature. Uh, I guess you will get digital humidity and temperature also in Tinkercad. DHT नहीं है ना, इसमें DHT भी नहीं है. In Tinkercad, it might happen that you might not get each and every component like rain sensor or DHT. So you can search for temperature sensor, like temperature sensor, and you will get a temperature sensor of which you can easily see which pin defines what. Uh, uh, put your cursor on every pin and it will show what it is, like the this pin is for power, V out, and ground. V out what? Signal. And what? Power that which goes in 5 volt, and ground is goes on ground. Okay, so first we'll do in Tinkercad. I request everyone to do the same parallelly, and if you have any doubt, please ask. Okay, so we will get a breadboard, small or mini, whatever you want. Connect the 5 volt, change the color. Connect the ground, change the color to brown or something. Get the temperature sensor, plug it in. Now the leftmost pin is for power, so we take a wire from power and put it in the 5 volt line. From the ground, we connect the ground. And the V out is used for uh, reading the signal or the reading the data from the sensor. So to any pins, any digital pin. I hope everyone was. I hope everyone was able to do this. Now the next sensor for the day is ultrasonic sensor. Ultrasonic sensor is used to find the distance between the sensor and whatever it comes with in the range of it. So we will delete everything what we set it up here. Search for ultrasonic, drag a sensor. You can see clearly there are 4 pins: VCC, trigger, echo, ground. We know the use of VCC and ground from beforehand. So what we will do, first bring a breadboard. This time I'll bring the mini. Connect the VCC to the 5-volt pin. Connect the ground from the ground. If you like, change the colors. Now, how the ultrasonic sensor, whatever it be in IoT or the original the ultrasonic which is used in ships and all, how does that ultrasonic works? We know that ultrasonic sends a sound wave or any form of wave which reflects back, and we calculate the time taken by the wave to come back. So there are two sensors, you can say, in this board. One sensor sends the signal or sends the wave, the other one receives it, okay, and then we will calculate the total time in the code. There is nothing like this ultrasonic will give directly the distance between the 2 points. We have to calculate the distance in the code. So we'll search for ultrasonic sensor. Okay, click a link, you'll see. Copy the code, paste. Okay, so there are 2 pins. One is the ping pin and the echo pin. Uh, you can read also in the this documentation that it first sends a signal, then it reflects back from the object, and it receives the reflected signal, and we calculate the time. So what happens? Uh, the ping pin will sends the signal, okay, or we say the trigger pin, ping or trigger pin. What on which number it is connected? It is connected in pin number 7. So we will connect the trigger or ping pin to pin 7, echo pin to pin 6. Okay, and now we will understand how the code is working. Define the pins in which pin number you are plugging in. Define the baud rate. It is called baud rate for for seeing the outputs in the serial monitor. As you know, there are different types of variables: int, float, double, etc., etc., long. Okay. So we are using long because it may exceed the range of integer. Uh, you can define it in the loop function, or also you can define in the setup function. Pin mode, ping pin. This pin is used for output. Output what? First we will send the signals, so that will count as output. Okay, so we write here output. Then we set that ping pin uh, as low because we don't want to send any signal right now. There can be two types of delays: delay microsecond and delay. Uh, then we set the ping pin high, send the signal. Okay, wait for 10 microseconds. Uh, then again switch off the sending signal, like this red waves. We switch it on just for 10 microseconds. Okay, then we take input from the echo pin. We measure how much time it takes. So, like first we turn on the sender for 10 microseconds. It receives some waves. It reflects back, and we just wait for 10 microseconds because the waves are so fast that if you wait for a second or two, it may not measure properly. So we wait for microsecond, and we measure the reflected signal from the echo pin. So we write echo input. First we gave output, wait for 10 microsecond, switch it off, measure the reflected waves, and now there is a function called pin in, built-in function which calculates the time, which calculates the distance uh, without any mathematical calculations. Or there are some codes which shows the which don't use this built-in pulse in function, and calculates the code in the program, calculates the distance in the program. I'll show it later. Then whatever duration we get, we know that the speed of light is speed of sound is approximately 340 meter per second. We divide it by 340, and we get the total distance, like 74 by 2, that is 320. So whatever be the speed of sound, we divide the total microsecond by that, and we get the distance. So we'll run the code. The green path which you see is the range in which ultrasonic can detect, and this is the our dedicated object of which we need to find the distance. Okay, you can drag it anywhere, and you will see the distance here, like actual distance. And now we need to see the measured distance by Arduino, that we'll see in the serial monitor. Okay, you can move this object anywhere you want within the range, not outside the range. Okay, within the range, there is a range of ultrasonic. It mostly ranges like 2 to 3 meter. You can put anywhere and see if there is a change, and if this the distance in the serial monitor is approximately equal to the actual distance shown in the simulation. After we complete this task on Tinkercad, we will physically use ultrasonic and see the distance. Okay, I'll give you a minute or two. Please do it in Tinkercad, and if you have any doubt, please ask. I hope everyone was able to do the ultrasonic. After Tinkercad, we will do a hands-on कि असली में अल्ट्रासोनिक को कैसे कनेक्ट करना है, कैसे मेजर करना है, ठीक है? What we did in Tinkercad was we will do exactly the same. Connect the VCC. First we will connect the VCC and the ground. Make a habit of uh, connecting VCC and ground with two different colors so that you don't confuse and interchange the wires. That will cause the components to damage. Okay, so we will take the red wire, connect in 5 volt. The red wire to be connected in the VCC of ultrasonic. Take the brown, put it in ground, connect the brown in the ground. Take any wire, put it in trigger or the ping pin which is used to send the signal, and according to the code uh, plug it in the pin number 7, and the echo pin which is used to receive the waves back, that was pin number 6. Copy the program, paste it in Arduino Ide. It's a good habit to recheck always the recheck the pins. Okay, we will make sure the boards is Arduino Uno. We will make sure the ports and upload. Once it's done uploading, you can open the serial monitor and see the distance, if the distance is correct or not. Okay, so this is ultrasonic. If I bring my hand closer to the ultrasonic, it shows like 8 centimeter or 2 inches. Like huh. If I bring too close, it shows 0 inch or less, like 1 centimeter. If I move my hand away, it the distance is slowly increases. Okay. Just as the same as like we did in a Tinkercad, but it's in the physical. So sometimes the distance may not be much accurate as we have seen in the Tinkercad. This is just like an approximate distance. The distance in inches is more approximate because to cover a inch it takes more centimeters. So I always prefer to measure the distance in centimeters. That's it for the day. Tomorrow we will discuss about the Node MCU, Wi-Fi enabled Arduino. Tomorrow we will learn more about relays and electronic switch, which we can control from the boards. We will learn tomorrow how to control appliances with Google Assistant. Any appliance which you have installed in your home, like fan, LED fan, light bulbs, anything. We will learn tomorrow more about IoT cloud platforms, which is the most essential part in the IoT, because the hands-on project which I did today was just the basics, and we understood how the VCC and ground pins work. So I hope all of you will join tomorrow. Thank you.